What's up, guys? Welcome to JS Racing. My name is Jason. Today, let's talk about exhaust system. It's always been a huge concern for us because for everything that we've tested, it's really not that great because our application is obviously circuit racing. All the options that we found are much more catered to road use. And road use and circuit racing are drastically different when you look at a power curve. Road use, it's more focused on the earlier parts of the RPM range where you need to get more torque to sort of, move from, red light or whatever. For circuit racing, although the initial boost of torque is important, the higher RPM range torque is even more important because, after you exit a corner, if you don't have enough torque at the higher RPM range, you're not going to be able to reach very high speeds. Very high top speeds, and that's going to be a problem for your overall lap time. So that's been a very big concern for us, and I'll show you what kind of exhaust systems we've tested. Now, if you look here, you can see a whole bunch of different tailpipes and headers, and I can tell you none of these are good. Okay, this kind of header has way too steep of an angle, so it's like basically a 90 degrees. That's pretty bad for the exhaust gas because there's a lot of pressure buildup, and this would be a good design for road use, but for circuit racing this actually causes a lot of problem. This is actually already an improved design from the manufacturer. Originally the port side of the header where it attaches to the cylinder head, the angle is a lot steeper, and when we tested that design, it would cause the engine to bog quite a bit. And in the beginning, we thought it was a carburetor problem. But then when we tested our very own version of the exhaust, we didn't have that problem. So we ended up finding out that it was because of the angle being too steep. So we asked them to sort of change it. It did improve, but because of these angles here, it's still not that good. And I'll show you a dyno run for this particular tailpipe. Now for this one, it's even worse because I need to show you a close-up a bit later. Not only are these angles a lot steeper, the pipe is a lot narrower, but the port side is even worse, and I'll show you a close-up a bit later. So these kinds of angles are really bad for circuit racing. It's just too stuffy, there's too much resistance, too much back pressure, and it's just causing a lot of horsepower drop. Now these tailpipes, okay, is a bit different. If you use a much better header and you attach these tailpipes, it will still give you a lot of problems because the exhaust exit side of the tailpipe, I suppose you can say that, it's just way too small. Like going in, it's that wide, and then coming out is like this tiny. It's just not going to work. It's just too stuffy, and it's way too short for the exhaust to travel. Same with this. There's only one, so it didn't work. The best performing one, at least more acceptable one, would be this one. It's long, so you have a bit more time for the exhaust gas to just drop in a lot of pressure so that, it can do like smaller ports exiting, but it's still not that great. So this particular version though, they did design a very large exit port, but then because of these two angles, it just didn't work at the end. So we don't use any of these tailpipes or headers anymore. What we do use now is our very own version, and that is this one. It looks kind of nasty because it's being used for a really long time now. It's a bit flimsy, but the header side, the port side, everything, the angles are very, I would say, less aggressive, and it's a completely open exit. So it's a lot better, and I only use this for power runs. So let's go back to the exhaust that I told you I would show you the port side. So if you look at that, that's a very steep angle. Like this is the port side, so that's a very steep angle coming down, and it immediately meets a very steep turn as well. And this is just a very bad design because it would basically cause the exhaust gas to get really backed up around this corner. So this is really, really bad. One of the worst ones that we've tried. Now this one, the one with the two right angles, the port side is a lot better. You can see that it's a lot better. There's really not much backing up, at least from this angle. But if you look on this side, it's still, you know, turning this way quite a bit. So originally, the very first version that we tried, it's even worse. It's a lot steeper as well. So that was causing a lot of problems. So once they changed to this angle, it's a lot better, but still it was causing a lot of problems for the power curve because of these two right angles. So we don't use that anymore. Now let me just show you our own, well, I wouldn't say our own, but like this is the one that we've been using for the longest time. So if you look from this angle, it's not a really steep turn, but there is a turn here where it's, you know, creating a bit of pressure, but it's not that steep. And then from this side, it's basically flat. So we're quite happy with that. But even with this OG version of the exhaust system that we sort of create, I wouldn't say created, but cobbled together, it's still not the best because you still have quite a bit of a turn here right at the beginning where it attaches to the port. So we have decided to create our own version where we have less resistance coming out, and then turning out, the angle here would be less pronounced, you know, more closer to a sort of straight line, but it wouldn't be a straight line, but more something like this. And hopefully that would reduce a lot of the pressure coming out directly from the engine and then out onto the tailpipe. So that's something that we're looking into doing. Well, I mean, we've already submitted the design to the manufacturer, but they're on holidays right now, so we'll have to wait for a bit, maybe like, I don't know, 2-3 weeks for it to come back. But I'll show you something real quick, basically how our design would be a bit different to what I just showed you with our OG version. So in this picture, I attached a couple of these red tubes. These red tubes are what you'd get from WD-40. So I attached a couple to the exhaust port, and I found that the angle of the exhaust port coming out, the gas is actually, like, if you look straight at the exhaust port, is actually directly perpendicular to the plane of the exhaust port. It's coming straight out. And then if you look to the side of the exhaust port, it's only coming down a little bit. So I ran the engine without the exhaust pipe, and I found that the flame shooting out coincides with, you know, what I saw from the little red tubes test. So what I did was I modified the sort of like the first portion of the exhaust, and I made a model, and I'll show you real quick. So this is something I 3D printed, and I'll be sending this to the exhaust pipe guy to help me model it. So if you look directly at the port, it's straight out, okay? But if you look to the side, it's sort of at a bit of an angle. It's not coming down a lot, but it's still at a bit of an angle. And this is basically exactly the angle where the flame is shooting out. So the exhaust gas should not experience much pressure, at least for this portion of the travel for the exhaust header. The angle would start coming in like that and then sort of draw out. But yeah, we're trying to have the angle as I would say as large as possible. So like 120 degrees or something, at least not the 90 degrees, you know, so it doesn't build up pressure, at least around this corner too much. Because what I had experienced before was that because the exhaust gas was hitting this corner so much, and if it's like a hot day or you're running for a really long time, this part would get heated so much that it will just weaken the metal and it will snap from this corner, and it's pretty bad, and I've experienced it before, so we don't want that to happen ever again. So yeah, we're changing that angle to be a much larger angle so that, you know, the exhaust gas is able to travel easier to the tailpipe. Now for the downpipe, like the end pipe, I'll show you a couple of power runs, and you will see just how much the tailpipe also affects the power curve of the engine. All right, so let's first look at our original exhaust. Okay, so just keep in mind what the power curve looks like. The dotted line is the horsepower and the solid line is the torque. Okay, so our torque peaks at around 3,000 and then gradually falls off until, I don't know, like 5,000 something, and then it falls off a bit quicker after like 6,000. But that's basically the, how it looks like for our original exhaust. It's rated at 15 horsepower. All right, next up, let's compare the original exhaust with the one with 2 right angles. So this one has completely different header and also tailpipe. This one is completely by itself. It's by a company called SKR, they make it. And if you look at the horsepower, it's already 1.3 horsepower less than the original exhaust design. But if you look at their power curve and torque, it's fairly similar to ours, but because it's more muffled, it doesn't really have a lot of follow-up torque past like 3,000. It drops off significantly quicker than our original exhaust. So ours start dropping off maybe like, I don't know, mid 3,000 to 4,000. There's a sort of start dropping off at the end of 2,000, something like that. So it loses out a lot of torque very, very quickly. So that's the one with the 2 right angle. And although it does have a big opening end pipe, it really doesn't help at all. So now next up, let's look at the one with the really long tailpipe and also with the black cap. Now this time we're using the same header. So it's the same header, exactly the same as our original exhaust, but only the end pipe is different. So you can see if the header is the same, but the end pipe is different, you can see already the muffled one, which is the blue line, it has a lot of torque early on in the lower RPM, but it drops off very, very quickly. So after it goes past 2,000, it starts dropping off. It starts falling down quite quickly. Whereas if you look at our torque, which is black line, the original exhaust, it doesn't really start dropping until after 3,000, and it's only a very gradual drop, whereas the blue line, the blue solid line, is a very quick drop. So even though it does have like 15.1 horsepower, it really isn't very ideal for circuit racing because, most of the time our engine will be operating at around 5,500 to 7,000, something like that. So that is where it loses a lot of torque. Whereas if you look at the black line, the drop is fairly gradual. So that's the one with the long end pipe with the black cap. That one is muffled, but yeah, it's really not that great either. It obviously it is an end pipe designed for road use for bikes, so it does explain itself with this power curve, but it's definitely not applicable for us. So next up, let's look at the short ones, the short silver ones with a really small opening at the end. And again, this one uses exactly the same header. Okay, so our original exhaust, okay, it's 15 horsepower. The short one is about 12.9, but it does show very similar characteristic with the long tailpipe with the black cap, and that is it has a lot of torque until like 2,000, and then it drops off very, very quickly. And this really shows that this really short one is not good because it's so short that it backs up on the exhaust pressure so much that it's really making the engine lose out on the torque a lot sooner than the one with the long black cap one. So yeah, these shorter ones are pretty bad. So again, it is a road use exhaust pipe, so I mean, it does explain itself, but yeah, definitely not good for circuit racing. So lastly, let's look at all of the exhaust compared to each other. The blue one is the original exhaust. The red one is the really long one with the black cap. The green one is the shorter one. And then the black one is the one with the 2 right angles. So the worst performing one is the green line, which is 12.9 horsepower. Then it's the SKR, which is the one with the 2 right angles at 13.7. And the 15.1 is the red line, which is the long tailpipe with the black cap. So let me just go back to the black line first. So if you look at the black line, the torque line profile is actually very similar to our original exhaust. It's very different to the road use ones. The red and the green, those ones are completely road use end pipes. They have like a lot of high torque in the very low end of the RPM, and it drops off very, very quickly. Whereas the black line, it does have a very similar curve compared to our original exhaust because it does have a very big opening on the end pipe. But because it has like two right angles, it's very, very stuffy. It is able to maintain a decent amount of torque throughout the RPM range, but it isn't able to push it any further because it's just way too stuffy for the engine to run. So yeah, it ends up being at 13.7 horsepower, 1.3 horsepower less than our original exhaust. So that's really not that great. So every time I do a power run, I would always have an exhaust pipe on the engine. The biggest reason for that is when you have the engine on your kart, you're going to have an exhaust on it. So we want to have a more realistic reflection of the power curve of the engine. So I always run power runs with the exhaust on, and I always do it on the OG exhaust. But the limitation for this kind of really just big opening kind of tailpipe is that you don't get the benefit of the lower end torque for more muffled systems or for systems where there's a lot more pressure buildup in the exhaust system. So we're working on another design that hopefully will give us the best of both worlds. So what we're hoping for this exhaust tailpipe would do is that at a certain RPM, it remains closed. And when it goes above a certain RPM, it will open by itself. So it'll look something like, it's a bit fatter, but it'll have like 3 ports, 2 small ones and 1 big one. I mean, this design sucks because I still need to tweak how the ports are laid out. But the idea is basically at lower RPM, it only comes out from these 2 small ones. So there's a lot of pressure. So that gives the system a lot more lower end torque. As it builds up, you know, to like 3,000, 3,500 RPM, which doesn't take long, this large port will open and remain open for the duration of the entire RPM range at the end. So like from 3,500 all the way to 7,000, 8,000, something like that, it will remain open. So it won't have as much resistance to the system, and it will allow the engine to climb to higher speeds a lot quicker. Because for the more muffled systems, the torque drop is really because of the tailpipe or the exhaust system having too much pressure buildup, and it doesn't allow all the exhaust gas to escape from the combustion chamber as quick as possible. So you have a lot of pressure buildup, and thus the engine's working harder to, you know, climb to quicker, higher torque or whatever. But at the end of the day, it's not able to do that, you know, because of all the pressure buildup. So the idea for this one is basically to alleviate that problem with muffled systems. So lower RPM, you have this more muffled sort of setup. And good thing is when the engine's idling, it's not as noisy. So at higher RPM, it'll open up. But another thing that we need to consider when we're working with this kind of system is that when the car is slowing down before a corner and then it needs to sort of accelerate and leave the corner, we need to make sure that the pipe is not opening and closing at the wrong time and then giving the engine unnecessary pressure or lack of pressure to allow it to go through a corner. So that's something we need to test and program into the sort of like the butterfly valve that's going to control this. But yeah, I mean, this kind of system is not anything new. I mean, Harley Davidson had something similar design, but they had like 2 different tailpipes. And I think Yamaha or whatever, they also have something like this. But for karting, this would be a first, I would say. So yeah, I mean, I don't know how easy or how hard this is going to be. The header, it's already that's basically dealt with because we already know what design we want. That's much easier to do. But this, I would need to do like programming, build circuits on it, figure out power supply, all that. So yeah, we're hoping that we can do all of that without adding too much cost to the overall system. And on top of that, we don't want the extra weight from like a 12-volt battery. So I need to figure something out, you know, have the engine generate electricity and then, you know, try to reduce weight or something. So I'm working on that. I've been working on that. I do have something like this that I built a while back. So what this is supposed to do is it will take the power from the lamp coil that is installed onto the engine. It doesn't add that much weight to it. And my original idea for this particular setup is just to power the Micron AIM because the AIM battery sucks. So this one is supposedly, there to just power the AIM, but I haven't been able to get it working yet because the lamp coil is broken. So I bought a new one, so I'm gonna start working on this particular thing as soon as possible just to see if it works. But yeah, that's the idea. But now I need to change this circuit so that it powers two more things. One is the butterfly valve, and then another one is like a microprocessor that would control the logic for opening and closing the butterfly valve. So I need to have 3 power outputs from 1 power input. So yeah, I need to work on that, and I'm not very good with electronics. So yeah, it's gonna take me some time to figure it out. But anyway, that's the idea. So the header and the tailpipe, we're still working on it. The header, I think we'll be able to see a version very, very soon, but the tailpipe, I don't know. I think for the meantime, we're just going to be using either this one, which is going to be very loud, or this one, because from the power run that we did at lower horsepower, this doesn't really affect the overall horsepower as much, although it does shift the power curve more towards the earlier part of the RPM range. But for 15 horsepower, compared to the original exhaust system, this adds actually 0.2 to it. So overall, this is a bit better at lower horsepower. So yeah, I mean, it does muffle the sound a bit more, so it's not as noisy, because a lot of circuits do have like a noise level requirement. So if we were to be required to meet that sort of noise level, we will probably be using this one. But honestly, I don't like the exhaust being muffled, to be honest, because it shifts too much of the power towards one side. So at the higher RPM, you're not getting a lot of torque. So that's the problem with the muffled systems. But anyway, that's pretty much it for this video. It's just really to show you guys what I've been working on. But yeah, I'll try to post more regular videos moving forward. I do have a tendency to sort of stop for long periods of time and then get back and then stop again. So yeah, but anyway, so that's it for this video. I'll see you guys in the next one. Peace.